Hello there, Mathletes. Welcome back to Math Jamboree. In this video, we have another AP Precalculus type of a question from the topic of polynomial function. Let's solve it together. The polynomial function p of x equals x minus 2 times x squared plus x minus 3. Which of the following describes the zeros of p? A, p has exactly 2 distinct real zeros. B, p has exactly 3 distinct real zeros. C, p has exactly 1 distinct real zero and no non-real zeros. And D, p has exactly 1 distinct real zero and 2 non-real zeros. To find the zeros of a polynomial, we're going to make factors equal 0 and solve for x. So in this case, this is the factor 1 and this is the factor 2. We have two factors. We will make each of them equal 0 and we will solve for x. So take away 2, add 2 to both sides since they did take away. X equals 2 for the first one. And here 3 times 1, x and x. When you add, can you get positive 1 from here? No, because there's no such a factor in 3 when you multiply. So in this case, you cannot easily factor this. This question is going to take a little bit more than a little bit unique difference actually from the other questions. So technically, we're going to use a quadratic formula to find its factors. So ax squared plus bx plus c equals 0. In this format, the a for this function, a is 1, b is also 1, and the c is negative 3, right? And let's write the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac divided by 2a. 2a. And we will substitute the values in now. X equals negative b. B is 1, so this is negative 1, plus or minus square root of b squared 1 minus 4 times a, which is 1. C is negative 3 divided by 2 times 1, 2. So, and continue, negative 1 plus or minus square root of, there are two negatives when you multiply turns into positive. So it becomes 1 plus 12 inside. 1 plus 12 is 13 over 2. So x1 in here with the positive 1, negative 1 plus root 13 over 2. And the x2 will becomes negative 1 minus root 13 over 2. So this is the root of these factors. These are the roots. So we have found negative 1 minus root 13 over 2 as the first one. And the second one is negative 1 plus root 13 over 2 and the 2. So as you can see, we have 3 distinct real zeros. These are real zeros because the root is not, if this inside of the root would be negative, then you would have said it's non-real zero. It's a complex number. In this case, these are all real numbers because the square root is not negative. That's why the correct answer will be choice B for the specific question. I hope you found this video helpful. If you did, please give it a thumbs up. If you have questions or comments, you can always leave it below there. Thank you and see you next time. Bye-bye.